Okay, this lesson is multiplying monomials and powers of monomials, and this covers basically two different lessons. We're going to go over a couple of rules and how those work. And we're going to learn to multiply monomials and define powers of monomials. So the first rule is the rule of exponents for products of powers. Okay, so basically what this says is if I have two powers, remember a power is just a number that's raised to an exponent. Okay, so a to the m is a power, a to the n is a power. And when we're talking about products, we mean multiplying. So if I have a power and I'm multiplying it by another power, if the base is the same, all I have to do is add the exponents. So for example, if I have x to the third power times x to the fifth power, that's going to be the same as x to the 3 plus 5, which is x to the 8. And if we think about this, if I have x to the third, that's the same as x times x times x. If I have x to the fifth, that's x times x times x times x times x. And if I count those, I have 1, 2, 3, 4, 5, 6, 7, 8. X to the eighth power. Well, instead of writing them all out, we look and see that all we have to do is add the exponents. This only works when the bases are the same. So if I have x to the second times y to the third, that's just going to be x squared times y to the third, okay, because they don't have the same base. It works also with if I have coefficients. So if I have something like 3n squared times 4n to the fourth, I can multiply the 3 and the 4 because those are coefficients. That would be 12. And since I'm multiplying n squared times n to the fourth, I can just add those exponents. So that would be 12n to the sixth. Okay. It also works with if I have fractions. I know you guys love fractions. So suppose I have 20 x squared y over 3. I'm going to multiply that times 12 x cubed y to the fifth over 5. When I multiply the coefficients. So 20 times 12 is going to be 240. I have an x squared and an x to the third, and since I'm multiplying, I can add them together, and that gives me x to the fifth. I have a y and a y to the fifth. Remember, this is a 1 here. So 1 plus 5 gives me 6, so I have y to the sixth. All over 3 times 5 is 15. And then hopefully I can divide 240 by 15 and come up with something that works. And it does. Yay me. It's equal to 16. So this becomes 16 x to the fifth, y to the sixth. Okay, and we're going to be doing a lot of stuff like that. So you need to make sure you understand these rules. So if I multiply two powers and they have the same base, then all I have to do is add the exponents. Okay, the next rule then is the rule of exponents for power of a power. And basically what that means, if I have a power, I have something that's raised to an exponent, and then I raise it to another exponent. And it's usually, actually it's always within parentheses. So the first one is within parentheses, and then the second exponent is right outside. In this case, instead of adding the exponents, I'm going to multiply them. So for example, if I have x to the fourth, and that's being raised to the fifth power, I would multiply 4 times 5, and that would give me x to the 20th. Now, if we think about this, that would be x to the fourth times x to the fourth, x to the fourth times x to the fourth times x to the fourth. So that's 5 times 1, 2, 3, 4, 5. Here I would add the exponents. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. Okay, but instead of writing it out like this, we know the rule, we just multiply. Okay, so it's really easy to get these first two rules mixed up. So you need to make sure that you know them. If I'm multiplying two powers and the bases are the same, I add the exponents. If I have a power and I'm raising it to another exponent, then I multiply the exponents. So another example might be, here's a good one, negative a squared to the third power. Okay. So that would be the same as negative a, we have to follow the order of operations. So negative a squared is just going to be a squared to the third power. So it would be 2 times 3, so it would be a to the sixth power. If I have a coefficient, so suppose I have 2x, and I'm raising that whole thing to the third power, this 2 has to be raised to the third power as well. Everything within the parentheses is raised to this exponent. So 2 to the third power is 2 times 2 times 2, which is 8. And then x to the third power looks like that, x to the third power. Okay, if I have something like, let's do 3x squared to the fourth power. Again, this 3 has to be raised to the fourth power, and that's going to be 81. X squared to the fourth power, it's 2 times 4, so that would be x to the eighth power. Okay, this last rule is the rule of exponents for a power of a product. And basically, I think I just explained it up here. But basically what it means is if I have two things being multiplied and they're in parentheses and it's being raised to an exponent, everything within the parentheses has to be raised to that exponent. So for example, if I have negative 2k to the fifth power, the negative 2 is raised to the fifth power. So since this is odd, it will be negative. 2 to the fifth power is 32, and then k to the fifth power is just k to the fifth power. If I have something like this, negative 3x squared y to the fifth to the third power, everything in the parentheses has to be raised to that third power. So negative 3 to the third power is going to be negative 27. X squared to the third power is going to be 2 times 3, so x to the sixth. Y to the fifth to the third power is going to be 5 times 3, so that would be y to the 15th. Okay. All right, so let's look at this evaluation down here. Now, it's 3 separate problems, but they look very similar. Okay, and we're going to replace the t with a 2. So if I start with this one, it's only the t that is being raised to the third power. Okay, so if I follow the order of operations, 2 to the third power is going to be 8, and 3 times 8 is going to be 24. Here, it's 3 times 2, and the whole thing is being raised to the third power. So follow the order of operations. 3 times 2 is 6, and then 6 to the third power is going to be 216. Here I have 3 to the third power, t to the third power. So again, plug in my 2. 3 to the third power is going to be 27. And 2 to the third power is 8. And 27 times 8 is 216. So you see these gave us the same answer, and it's because they both represent the same thing. 3t in parentheses raised to the third power is the same as 3 to the third power times t to the third power. Okay, and for the try this, there's 4 problems. Make sure you go back and you look at the rules carefully and work these problems out and put the answer in the try this.